The global banana industry, worth more than $30 billion annually, leaves behind over 200 million tons of post-harvest waste, an enormous amount capable of filling tens of thousands of the world's largest stadiums. But what if these materials, once considered worthless, could be recycled and even sold for more than their original value? From banana fibers transformed into clothing, wigs, writing paper, and even sanitary pads, to fertilizers and biochar, innovative recycling methods are giving the banana plant an entirely new life cycle. But can these models truly turn millions of tons of banana waste into a valuable resource for the future? Join Terran Works as we explore the answer in today's video. To understand why banana plant recycling is attracting growing attention, we must first look at the scale of the industry. Every year, the world produces approximately 180 million tons of bananas, making them one of the most widely consumed fruits on the planet. India is currently the world's largest banana producer, followed by China. In terms of per capita consumption, however, Uganda stands out as one of the most remarkable markets. People there consume roughly 220 to 400 kilograms of bananas per person each year, at times equivalent to nearly 1 kilogram every day. Bananas owe their popularity to their affordability, convenience, and high nutritional value. A medium-sized banana provides around 110 calories, 3 grams of fiber, and 450 milligrams of potassium, along with vitamin B6, vitamin C, and magnesium. In many African countries, bananas are also considered a staple food. Each banana plant produces fruit only once. After the bunch is harvested, the old pseudostem must be cut down to make room for a new shoot. Nearly 80% of the plant's biomass can become agricultural waste, resulting in approximately 114 million tons of discarded material worldwide every year. When piled up, this waste occupies valuable land, attracts insects, and increases the risk of pests and plant diseases. When burned, it releases smoke and carbon dioxide, contributing to environmental pollution. Even when left to decompose naturally, it quietly produces methane, a greenhouse gas with a far greater warming effect than carbon dioxide. So what can be done with this enormous volume of waste? Instead of treating it as useless material, factories around the world are beginning to recognize the hidden value inside these rough, fibrous plants, and that is where a new recycling chain begins. As fast fashion pushes the planet deeper into a massive waste crisis, banana stems and peels once abandoned in the fields are undergoing a remarkable transformation, emerging as a new star of modern handcrafted fashion. The process begins with fresh banana pseudostems collected from farms. They are cut into sections, separated into layers, and fed into fiber extraction machines. The machines remove the soft tissue and moisture, leaving behind only the long fibers running along the length of the plant. After extraction, the fibers are washed, dried in the sun, and combed to remove impurities and shorter strands. They are then sorted according to length, softness, and strength. To produce fabric, banana fibers must be boiled or otherwise treated to reduce their stiffness. They are then combed into finer strands, spun into yarn, and often blended with cotton to make the material softer. The finished yarn is woven into fabric before being dyed, cut, and sewn into shirts, dresses, scarves, and fashion accessories. Banana fiber can feel almost as soft as silk while remaining strong and durable like rope. Longer fibers are twisted into cords, then woven and tightly compressed on looms to create rugs with a natural texture and impressive durability. Shorter fibers, or those unsuitable for textile production, are still used to make handbags, wallets, baskets, table mats, lampshades, pencil holders, and various decorative products. Their natural colors, distinctive designs, and connection to local craftsmanship make them popular as souvenirs and gifts, especially among tourists. A single banana fiber rug can take around 1 month to complete and may sell for $500 or more. It turns out the joke, whatever the problem, there's always an Indian guy on YouTube who knows how to fix it, may actually be true. Would you believe that a single banana plant can be recycled into as many as 3,000 sanitary pads? products that are biodegradable, while also helping more women gain access to safer menstrual care? This innovation tackles two major problems at the same time. India discards around 12.3 billion sanitary pads every year, generating nearly 113,000 tons of waste. Most conventional pads contain plastic and can take centuries to break down. Meanwhile, the NFHS 5 survey found that only about 77.3% of women aged 15 to 24 use safe menstrual hygiene methods, meaning that nearly 1 in 4 still lacks adequate access. The process begins with banana pseudostems collected from farms. The stems are separated into layers and fed into fiber extraction machines. The extracted fibers are then washed, dried in the sun, and transported to the factory. At the facility, the banana fibers are cut into smaller pieces and processed into a soft, highly absorbent pulp. This material forms the core of the sanitary pad and is placed between layers made from plant-based materials. The pads are then cut to size, tested for absorbency, fitted with a non-toxic adhesive layer, and sterilized using light-based treatment. Finally, each pad is individually packaged and heat-sealed. Remarkably, even the outer packaging is made from plant-derived materials. As a result, the product can decompose in soil in less than 6 months, around 1,200 times faster than conventional plastic-based sanitary pads. This innovation not only reduces agricultural waste and plastic pollution, but also creates additional income for farmers, employment opportunities for women, and better access to menstrual hygiene products in rural communities across India. What if the banana pseudostems left behind in a field yesterday reappeared today as a smooth, flowing wig worth more than $200? It may sound unbelievable, but in Uganda and Nigeria, this agricultural waste is now being transformed into hair extensions that are lightweight, durable, and more environmentally friendly. The process begins with fresh banana pseudostems collected from farms. They are separated into layers and fed through fiber extraction machines. Suitable fibers are selected, thoroughly washed, dried in the sun, and combed several times to remove soft plant tissue and shorter strands. Because raw banana fiber is naturally stiff, it is then boiled and treated with softening solutions until it reaches the required fineness and flexibility. The fibers are subsequently dyed in a range of colors, dried, and combed again for a smooth finish. High-quality bundles are woven or attached to a hair base to create extensions, braiding hair, and complete wigs. The finished products have a distinctive texture, weigh far less than many synthetic alternatives, and do not create the same heavy feeling on the head. Even the small fiber fragments produced during combing are reused as stuffing for pillows or as materials for handicrafts. This model not only reduces the amount of banana waste burned or left to decompose in fields, but also creates employment for women, hairstylists, and other local workers. Although the product is still relatively new, it is attracting growing attention because of its consistent quality, lightweight structure, and natural origin. From Africa to Europe and North America, banana fiber hair is gradually carving out a new niche in the sustainable beauty industry. Beyond fashion and beauty, the banana plant is proving remarkably versatile by entering another field, agriculture, where it is helping restore degraded farmland. One documented project covered approximately 4 hectares and involved 22 farming households. Between the banana plants, farmers dug pits at 0.6 meters wide and 0.45 to 0.6 meters deep. These pits were then filled with chopped banana pseudostems, leaves, animal manure, and soil. As the organic material decomposed, it gradually formed an underground reservoir of moisture and nutrients. Thanks to their porous structure, banana stems help retain rainwater, while the decomposing organic matter slowly releases nutrients to the roots. After around 3 to 4 months, the banana roots begin growing toward the pits to absorb the stored moisture and nutrients. This method is particularly effective in areas with depleted soils or frequent water shortages. In addition to maintaining soil moisture, the pits slow surface runoff, reduce erosion, and gradually restore soil fertility with almost no need for machinery or chemical fertilizers. In one documented project in Uganda, banana bunch size and crop yields increased by more than 300%. Banana pseudostems are not only useful for producing textiles and handicrafts, they can also become a raw material for papermaking. After the fruit is harvested, the cellulose-rich pseudostems are cut into smaller pieces, processed to extract the fibers, and thoroughly washed to remove sap and any remaining soft plant tissue. The banana fibers are then cooked to soften them before being ground with water into a pulp. This mixture is spread evenly across a mesh screen, pressed to remove excess water, and either sun-dried or mechanically dried into sheets. One study using the soda pulping method produced approximately 36.7 kilograms of pulp from every 100 kilograms of dried banana pseudostem under optimal conditions. Depending on the treatment process, the finished paper may retain its natural brown color or be lightened for use in packaging, paper bags, greeting cards, notebooks, and decorative products. Instead of cutting down more trees to manufacture paper, this method makes use of the banana pseudostems left behind after every harvest. After each harvest, banana stalks and bunch stems are often discarded in fields or left behind at local markets. However, scientists in the Indian state of Odisha have discovered that this waste contains significant amounts of potassium and can be converted into biochar for agricultural use. The raw material is first washed, cut into small pieces, and then sun-dried or mechanically dried to remove moisture. The dried banana stalks are subsequently placed inside a thermal plasma reactor. Under controlled high-temperature conditions, the biomass does not burn completely into ash. Instead, it is transformed into a porous, carbon-rich form of biochar. The resulting product contains approximately 5 to 15% water-soluble potassium, making the nutrient more readily available for plant uptake. The biochar is also alkaline and highly porous, allowing it to improve acidic soils, retain moisture and nutrients, and store carbon in the ground. Not only can post-harvest banana stems be recycled, but even the peels discarded every day can be transformed into nutrient-rich compost. Banana peels account for roughly 40% of the fruit's total weight, meaning that every ton of bananas consumed can leave behind nearly 400 kilograms of peel waste. The peels are chopped into smaller pieces and mixed with dry leaves, straw, sawdust, animal manure, and other organic materials. The mixture is kept moist and turned regularly to introduce oxygen, allowing microorganisms to break it down more efficiently. Once the compost has fully matured, the material becomes dark, loose, and crumbly, with a natural earthy smell. In one study, banana peel compost samples contained more than 100 grams of potassium per kilogram and over 2% total nitrogen, highlighting their potential to supply nutrients, improve soil structure, and increase water retention. Instead of being sent to landfills, every kilogram of banana peel can return to the farm as organic fertilizer, completing a simple natural cycle. Nutrients from the soil produce the fruit, while the discarded peel goes back into the ground to nourish the next crop. In 2025 alone, the world generated approximately 400 million tons of plastic waste. Much of it came from convenient packaging, used for only a few minutes, but capable of remaining in the environment for hundreds of years. Faced with this challenge, an Egyptian company has developed a more environmentally friendly form of packaging from an unlikely material: banana pseudostems. In Sohag Governorate, the Pyrus Egypt factory collects post-harvest banana pseudostems from around 2,500 acres of nearby plantations. Once they arrive at the facility, the stems are cut into uniform sections and fed through a mechanized production line. The machines separate the long fibers from the soft tissue and liquid inside, creating a clean raw material ready for further processing. The fibers are then molded into egg trays and various types of food packaging. Each production line can manufacture around 2,000 items per hour, with a total designed capacity of up to 100 million products annually. Meanwhile, the organic liquid extracted during processing is also being studied for fertilizer production, allowing nearly the entire banana pseudostem to be put to use. What is most remarkable is not only the products being created, but the way people are learning to see opportunity in materials once dismissed as waste. In the future, banana plants may no longer be grown solely for their fruit. The parts left behind could generate additional income for farmers, create new jobs, and prevent millions of tons of agricultural waste from being discarded every year. To understand why coconut husk recycling in India has become so noteworthy, we first need to look at the country's position in the global coconut industry. India is currently the world's largest coconut producer, accounting for more than 30% of global coconut production. Across more than 2.1 million hectares, the country produces over 21 billion coconuts each year, with an average yield of nearly 9,900 coconuts per hectare. But in India, the coconut tree is not just an agricultural crop. It is the livelihood of around 30 million people, including nearly 10 million farmers, concentrated in states such as Kerala, Karnataka, Tamil Nadu, and Andhra Pradesh. From a single coconut, the water can be used as a drink, while the flesh can be processed into coconut oil, coconut milk, dried coconut, or food ingredients. The coconut shell can become charcoal, fuel, or handicrafts. The problem lies in the outer fibrous husk. It is light, porous, bulky, takes up a lot of space, and is difficult to transport over long distances at low cost. As the coconut processing industry expands, the volume of this byproduct also increases. Notably, only around 30% of coconut husks in India are currently used effectively, meaning the rest remains a massive resource that has not yet been fully exploited. In small-scale processing areas, coconut husks were once piled up along roadsides, beside workshops, or near collection points. They are not toxic like plastic, but they decompose slowly, take up space, and can produce smoke and dust if burned in the open air. It is this paradox that makes coconut husks valuable. Inside the layer once seen as waste are strong coir fibers, moisture-retaining cocoa peat, and carbon-rich coconut shells, materials that can open up an entire new recycling chain. In India's coir industry, erosion control nets are among the higher value products. In a country that regularly experiences heavy seasonal rainfall, hillsides, canal banks, and agricultural land are highly vulnerable to being washed away by water. For this reason, nets made from coconut fiber have become a natural solution for holding soil in place and restoring vegetation. The process begins with coconut husks after the water and flesh have been removed. The husks are collected, soaked, or softened so that the fibers can be separated more easily. Then, fiber separating machines break apart the thick husk layer, separating the long fibers from the cocoa peat and fine dust. The long coir fibers are then cleaned, dried, and combed out to remove impurities. After that, they are twisted into longer and stronger strands. This is the main material used to weave the nets. Once the weaving process is complete, the coir nets are rolled into large rolls for transport to construction sites. In areas that need erosion control, the nets are laid directly over the leveled soil surface, then secured with wooden stakes, bamboo pins, or metal anchors. What makes coir nets special is that they do not protect soil in a rigid way like concrete. When rain falls, the coconut fibers help slow down the flow of water, reduce the force of erosion, and retain the topsoil. As a result, grasses and plants have more time to take root and regrow. Over time, the coir gradually decomposes and returns organic matter to the soil. This makes the material suitable for projects that aim to limit plastic use, reduce concretization, and prioritize solutions that are closer to nature. Alongside the long coir fibers used for weaving nets, the small fragments left over after the coconut husk separation process are also not wasted. During fiber extraction, machines break the coconut husk into two main parts: long coir fibers and fine fibrous dust. This dust is cocoa peat, a type of growing medium now widely used in modern agriculture. The treatment process begins when the cocoa peat is separated from the long fibers. It is then washed to remove dirt, impurities, and reduce the natural salinity remaining in the coconut husk. Next, the material is dried, ground, screened by size, and checked for quality. The parts that meet the required standards are compressed into blocks, packed in bags, or made into specialized growing bags for agriculture. What makes cocoa peat special is its ability to retain water very well, while still allowing enough air for plant roots to grow. In greenhouses growing tomatoes, strawberries, cucumbers, flowers, or seedlings, cocoa peat helps roots anchor firmly, retain moisture for longer, and reduce dependence on natural soil. For areas with degraded soil, saline soil, or difficult farming conditions, this growing medium opens up a cleaner and more controllable way to grow crops. From fibrous dust once seen as a low-value byproduct, India has turned cocoa peat into an important export product. Today, the country's coir products are present in 121 countries, with export volume of more than 1.3 million tons each year, reaching markets from the United States and China to Europe, Australia, and the Middle East. What would happen if the coconut husk you threw into the trash yesterday came back today in the form of a mattress worth hundreds of dollars? It may sound unreasonable, but in India, after the coconut water and flesh are removed, the thick outer husk is sent to factories for fiber extraction. The long, tough, and durable coir fibers are cleaned, dried, and then combed out to remove dust and impurities. Next, they have to be curled to create natural elasticity, almost like tiny springs made from plant fibers. After that, the curled coir fibers are steamed or heat-treated to retain their shape. Once they reach the right moisture level, they are spread evenly into thick layers on the production line. This forms the core that gives the mattress firmness, breathability, and support. Next, the factory sprays latex, or natural rubber, onto both sides of the coir layer. Latex acts as a binder, helping the fibers stick firmly together while still maintaining elasticity. From here, the rubberized coir sheets are cut to mattress size, pressed to adjust their thickness, cooled, and then covered with fabric. The difference of a coconut fiber mattress lies in its breathability. Because the inside of the mattress core is a network of natural fibers, air can circulate better than in many dense materials. This makes coconut fiber mattresses popular in hot and humid climates, where users need a firm, cool sleeping surface that does not trap too much heat. Beyond serving the domestic market, India's coir products are now present in more than 100 countries. In fiscal year 2025 alone, India exported more than 1.3 million tons of coir and coir products to 121 countries. In India, coconut shells are collected from coconut processing facilities, then cleaned to remove any remaining flesh, sand, soil, and impurities. Next, they are sun-dried or mechanically dried to reduce moisture. This is an important step because the drier the shells are, the more stable the anaerobic burning process becomes, producing charcoal of better quality. Once they reach the proper dryness level, the coconut shells are put into carbonization kilns. Under the effect of heat, the organic matter in the shells gradually decomposes, water vapor and volatile gases escape, and what remains is solid black carbon. After leaving the kiln, the coconut shell charcoal is cooled, crushed, and screened by size. Some of it can be sold as fuel for cooking, furnaces, or small industrial facilities, but the higher value portion continues to be processed into activated carbon. To produce activated carbon, coconut shell charcoal goes through an activation process using steam or high temperature. This step creates countless tiny pores inside the charcoal particles, increasing their surface area and absorption capacity. Thanks to this special structure, activated carbon made from coconut shells can retain odors, colors, organic impurities, and many pollutants in water or air. For this reason, coconut shell activated carbon is widely used in water filtration systems, air purification, wastewater treatment, the food industry, and many other manufacturing sectors. From a hard shell layer that once seemed useful only for burning, factories can create a high-value filtration material that serves both everyday life and modern industry. Not every coconut shell goes into the charcoal kiln. Some shells with beautiful shapes, hard surfaces, and a natural brown color are kept for a more delicate journey, becoming handicrafts. Artisans select shells with few cracks, a beautiful curve, and a surface thick enough to work with. They then begin cutting the shell into two halves, drilling holes, grinding the edges, sanding the surface, and polishing it with natural oil or wax. After just a few steps, the originally rough shell gradually reveals a glossy brown color, natural grain patterns, and shades that are never exactly the same from one piece to another. From a small coconut shell, people can create bowls, cups, spoons, decorative lamps, buttons, storage boxes, bracelets, earrings, mini plant pots, or souvenirs for tourists. Coir rope is one of the oldest products in India's coconut industry. In coastal areas, this type of rope was once used for tying goods, securing objects, agricultural use, fishing, temporary construction, and many everyday handicraft tasks. The long coir fibers are straightened, gathered into bundles, and fed into rope twisting machines. Many small fibers are twisted together to form thin cords. Then several thin cords are twisted again to create larger ropes, depending on the required thickness and purpose of use. After completion, coir ropes are rolled into large coils for transport to other workshops. Some are sold directly as tying ropes for agriculture, gardening, decoration, packaging, or handicrafts. The rest becomes an intermediate material for weaving mats, making erosion control nets, hanging planters, baskets, small furniture, and many other bio-based products. Compared with plastic ropes or nylon ropes, coir ropes are not always stronger in terms of tensile strength or lifespan. For this reason, coir rope is not only a traditional product, it is also an important link that helps India's coir industry move into many new fields. Among the many products made from coir mats are probably the most familiar. They appear in front of homes, in hotels, restaurants, resorts, and even in spaces that need a durable, naturally rough mat capable of cleaning dirt from the soles of shoes. After the coir fibers are separated from the husk, the long and strong fibers are selected specifically for making mats. They are cleaned, dried, combed out, and then classified by length and coarseness. For traditional woven mats, the coir fibers are spun into long yarns before being placed on a loom. There, the fibers are woven horizontally and vertically to create a firm, thick mat with a naturally rough surface. It is this rough surface that helps coir mats scrape away soil, sand, dirt, and water from shoes better than many ordinary soft mats. In more modern factories, coir fibers can be fed into tufting machines or pressing machines to create mats with uniform sizes. Some types are also dyed, printed with patterns, trimmed around the edges, or coated with an additional rubber or latex layer underneath to increase grip and reduce slipping on floors. Thanks to their durability, abrasion resistance, and plant fiber origin, coir mats are not only a familiar household item, but also a product with a more eco-friendly image compared with many mats made from synthetic plastics. Of course, coconut husk recycling cannot solve every environmental problem on its own, but it shows a very noteworthy direction. Instead of treating agricultural byproducts as a burden, we can turn them into resources, creating additional income for farmers, jobs for craft villages, and more sustainable products for the global market. Which product made from Indian coconut husks impressed you the most? Erosion control nets, cocoa peat, coir mattresses, coconut shell charcoal, or handicrafts?